Okay, so without further ado, we'll get into the webinar. So today I will be speaking about managing cybersecurity risks in wireless control networks, both for the wireless control networks themselves and for remote access procedures. I'd like to start off by introducing myself. My name is Patrick O'Brien, and I'm responsible for different consulting tasks in applications for functional safety and cybersecurity. Just a little bit of background on exida. Exida is a customer-focused company, and we try to bring our deep knowledge and understanding to your projects so we can help you achieve cybersecurity and safety while optimizing the process. And we do this through powerful lifecycle tools, certification and assessment, and also comprehensive lifecycle assessment. So we see that these three areas really work together and allow us to offer a full range of solutions. exida is also a global company, so we have a global customer focus. So hopefully you see an exida location on the map that's near you, but even if you don't, we do have the resources to support companies all over the globe, and we work in various industries. So we work with, chemical process industries. We also work with oil and gas, as well as with alarm management, automotive, and the power industry. So we really do try to cover a wide range of different industries and different customer-focused tasks. We'll also just touch briefly on our cybersecurity offerings. So exida really focuses on providing a pragmatic cybersecurity approach. And so what this means is we're not trying to give you 1,000 lists of threats or 1,000 different threat vectors that you have to worry about and recommendations. That kind of results in paralysis by analysis, and you have too many things to look at and you're not really sure where to start or what to do. We focus on giving actionable recommendations that support a pragmatic application of cybersecurity. And we do this through our consulting services, certification, training courses, as well as tools and reference material. For our cybersecurity services, we offer services that really go across the entire cybersecurity lifecycle. So whether we're in the initial phase of a project and just completing a gap analysis, or we're really getting into the analysis and design phase, we provide services that can help all the way through. And we also provide services that can provide usable recommendations for customers regardless of what their level of adaptation of cybersecurity policies and procedures are yet. So even if you're just getting started with cybersecurity, or if you've been implementing cybersecurity for a long time, we do offer services that can be helpful to you. We kind of follow a similar approach in cybersecurity certification. So we have tailor-made certification programs that can help you to get certified, whether it's a process certification, a device certification, or even a system certification for manufacturers and integrators. In addition to the certification for processes, devices, and systems, we do help with personnel certification. So I don't know if anyone here is familiar with the CFSE exam, but the CAC is the cybersecurity equivalent of this. So it's really showing that you do have the professional competency to perform cybersecurity tasks. To support this, we also have cybersecurity training. And so we offer a wide range of courses for the cybersecurity lifecycle, and these courses are focused both for security software development, as well as cybersecurity for employees and contractors, and even cybersecurity for integrators. So we really do have training courses that are relevant to all the different stakeholders in IACS systems. Next, we have many cybersecurity tools and references that can support the completion of cybersecurity lifecycle tasks. The first that we're going to talk about is a new cyber book, Implementing IEC 62443, A Pragmatic Approach to Cybersecurity. The book is actually live on our website for pre-order, so if you're interested in getting a copy, please check it out at exida.com, and if you go under reference materials, you should be able to find it pretty easily. We also have software tools. So for the Excellentia platform, we've developed Excellentia Cyber, which composes of two modules, CyberFacts and CyberSL, and these help you to complete different lifecycle tasks. We also have policies and procedures that can be used for different steps of the cybersecurity lifecycle. So now I'm going to cover kind of the brief topics that I'll be speaking about today. So the first topic I'll discuss is the industrial Internet of Things and how that's kind of becoming the new standard and the new reality in the automation industry. Next, we'll talk about basic risk management practices for industrial control systems, and then also review some case studies that are relevant to IACS and SCADA systems. Finally, we'll go in and discuss different steps that can be taken for securing remote access and securing wireless networks. So we're going to jump into the industrial Internet of Things, but before we do that, I'm going to open up a second poll just to get an idea of what backgrounds people are coming from. So the options are IT background, OT, maybe a little bit of both, or maybe a different background. So please, feel free to respond in, and we'll just get a quick idea of what backgrounds we're dealing with, and we can look at that. So I'll leave that open, for around 30 seconds. We'll see if we can get most people voting. So right now it looks like we're in a two-way tie between OT and other, with some IT and some both. So I'll give it just another 5 seconds and then I'll publish the responses. Okay. So it's nice to see that we do have a bit of a mix of attendees. So definitely focus a lot on OT more than IT, but it is good to see that we do have IT as well. And then we also have other, so maybe different engineering disciplines, a little bit of a different scope. So it's good to know just kind of what backgrounds we're working with when we go through the presentation. Okay. So when we talk about the industrial Internet of Things, it's often helpful to start with the traditional Internet of Things. And so just the basic, dictionary definition for this is the networking capability where we're getting information sent and received from objects and devices. So the example they give, would be a smart kitchen appliance. So maybe it's just you've got a refrigerator that sends updates to your phone, hey, you left the door open for, more than a minute. Something's probably wrong here, go check it. So, really just that next level of connectivity for consumer devices. But when we start to look at the industrial Internet of Things, that's much more what we're focused on today. And so that is really taking this connectivity between industrial devices. So understanding how the sensors, devices, and machines that contribute to the physical business process or industrial setting are actually now communicating through greater connectivity. And so before we go on to the next slide, we're going to hop on to the third poll, and we're going to talk a little bit about Industry 4.0. So just get a quick sense of how familiar people are with the term Industry 4.0. Alrighty, so we're getting good split right now. I'll give another 10 seconds and then we'll look at the responses. Okay. So what we found is that, somewhat of an even split, a little bit more than half saying no, a little bit more than half saying yes. So we'll dive into that and we'll give a quick overview of Industry 4.0. So Industry 4.0 is also referred to sometimes as the smart factory or the fourth industrial revolution. And so just going through some background on it, we see that the first industrial revolution is what most of us probably think of when we think of the industrial revolution. So this is when mechanization and the use of water and steam power really came into effect, and we started to see what we think of when we think of the first factories. The second industrial revolution came with the introduction of electricity, and this is also around the time we saw mass production and the assembly line being used for automobiles and other products. The third industrial revolution occurred when computers and automation actually started to enter into the control and production scene. And that's kind of, where we are today is now moving from the third industrial revolution to Industry 4.0. and this is the focus on cyber physical systems. So a cyber physical system is essentially you've got a device or machine measuring some sort of process or phenomenon in the real world, taking measurements, and then sending them to a virtual model of the world. And so now there's kind of decentralized decision making and communication over the Internet of Things that then influences the physical world. So it's the idea that the industrial Internet of Things is the way that machines are now communicating in the process industry and really, manufacturing and all different types of industry, and now kind of figuring out how they communicate and this next level of connectivity, this next industrial revolution. And when we start to think about why this Industry 4.0 might be important, it's good to kind of take a second and think about Moore's Law. So Moore's Law can kind of simply be summarized as the computing power doubles every 18 months. So we see that this will lead to an exponential growth in technology. And so as it doubles, each time we get stronger and stronger computers, more and more ability to connect better, do different, more complex tasks. And I was attending a lecture series on this topic in Germany a couple of years ago, and the speaker used a really helpful analogy that I'm going to take advantage of here. And that was, he talked about the man who invented chess. So it occurred back in ancient India, and this man, inventor, discovered the game and brought it to the emperor and showed the game, played a game, and the emperor was just blown away. He thought it was really impressive discovery and wanted to give the man a good reward. So he said, name whatever you want and it will be yours. And so the inventor said, all I want is very simple. I just want 1 grain of rice for the first square on the chessboard, 2 for the second, 4 for the third, and doubling each time. The emperor was, shocked by how simple of a request this was and said, of course, it's done. Later, the emperor goes back and speaks to his treasurer, and all of a sudden he starts to see that they have a problem because there are a total of 64 squares on the chessboard. And so when you double it each time, by the time you get to the last chessboard, you're looking at 1.84 e to the 19th grains of rice. So this is trillions and trillions of grains of rice, and it just goes to show how quickly things can grow with an exponential curve. So this kind of relates back to Moore's Law and understanding how the industrial Internet of Things is shaping automation systems. It's important to understand that we're getting to the second half of the chessboard. So we're no longer in the time where the doubling is only causing small changes. We're really starting to get into the exponential growth. So, every 2 years, we're seeing much more technological advancement. So it's really important to stay, aware of the current technology and, understand how this is going to impact us in the future. When we think about specifically IACS and SCADA systems, industrial Internet of Things is important basically because it can save time and save cost. So it allows for easier operations and maintenance, and we see that this is particularly true for remote systems. So if we imagine, just a general chemical plant, they have tank farms with their reactants and different chemicals that they need, and oftentimes these are stored remotely, so maybe 10, 20 miles away. Well, if an operator has to go out there and manually check the levels of these tanks every day, we can see that that ends up being a lot of time. But using a remote system, they could all of a sudden just be checking that in minutes or seconds and getting that same information. So this can lead to decreased operational costs. It can also lead to more efficient operations by only using electricity when it's needed. Further process optimization. So where we're at today using computer automated systems, we really have optimized them quite a great bit. But when we use the industrial Internet of Things, there's actually the potential to get kind of that last amount of optimization, which can be really significant from a business perspective. It can also be used for inventory and spare tracking. So that would be, part of your mechanical integrity program, making sure that you have visibility from, where your components are and whether or not they're ready to be put into the system. Then when we go on, we can look at 2 different common industrial Internet of Things technologies that are being used today. So this will be our next poll option. So do you currently work with industrial Internet of Things at your plant? So, for all the operating people or things, is IIoT currently used? So we'll give 30 seconds for that and kind of look at where the results are. Okay, we got a good amount of responses, so we'll close it and we'll just take a little bit of time to look at them. So what we see is that most people, yes, are currently using, industrial Internet of Things technology. Only a small percent, 15%, is not currently looking at them, and then the next largest group is looking into it to the future. So we're kind of in the middle of adapting it, and I think that is pretty consistent with what we're seeing in industry. So some people are currently using it, many people are looking into it for the future, so it's kind of a developing time for it. And today what we'll focus on are, the two main technologies that we're seeing for industrial Internet of Things. And the first is wireless LAN, or Wi-Fi, what we think of. And so that's got some benefits, some drawbacks. And the second that we're going to look at is sensor-based. And this is more based off of Modbus protocols or different proprietary protocols similar to it. So for wireless LAN, what we see is it has a lot of benefits based on its standardization. So it's interoperable even for older computer-based systems. So typically it's not too hard to retrofit and give them the ability to log on to Wi-Fi access. And this makes it really easy to deploy and integrate into an existing system. So you can get a quick system set up, have it speaking over Wi-Fi, and see results that way. Some drawbacks for it, though, are that it does have a limited range, and it does provide it provides a greater attack surface for threat agents. When we look at sensor-based, we see that it's not as standardized because there are so many different communication protocols. And so even though Modbus is the most common, there are still many other options that some control systems use. This leads to a more difficult deployment and integration, but if you are able to get the system set up, it does give you improved range over wireless networks or wireless LANs, but we do still see that it has a greater attack surface than not having the wireless network. So just out of curiosity, we're going to see people using wireless Internet of Things technology. Do we see traditionally, wireless LAN, or do we see more sensor-based? So the poll's out now. We'll give it, maybe 30 seconds, get some responses. All right, got a good amount of responses. I just want to say thank you guys for being an active audience. It really is great and makes the presentation feel a lot more communicative. So it looks like what we've got in terms of results are a majority using wireless LAN, a good amount of sensor-based, some other, and then some currently not using wireless technology. So that's, again, about what we expected because wireless LAN is much more easy to set up. But then there are some benefits to sensor-based technologies. So we're going to kind of transition from general industrial Internet of Things and then start talking about considerations for cybersecurity risk management in wireless control networks. So just basically, facility risk management should be done on a company-wide level, and it requires careful consideration both of the potential process hazards as well as the physical hazards as well as the cyber attacks. And so this really becomes important because cyber attacks are no longer just stealing data or a denial of service type attack. Attackers can actually gain access to controls and change physical processes occurring in the plant. So it's really important to have understanding both of the process hazards as well as the cyber attacks. To support this, there have been multiple international standards detailing a full lifecycle approach for guidelines for the analysis phase, the design phase, and as well as the operate and maintain phase. And these can be applied to both safeguards and countermeasures to limit this cybersecurity risk. So when we look at cybersecurity, the cybersecurity lifecycle is defined by IEC 62443. So we'll just do a quick poll and see, kind of what the level of familiarity with IEC 62443 is, and how much this is being used in plants. So again, we'll just take 30 seconds, get some responses, and then we'll see where we're at. Okay. All right, good responses. We'll share the results now. So we see that 10% or so are very familiar with standard, which is great. We see that around half is somewhat familiar, so we're starting to use a standard, and then around another half is not super familiar. And luckily, people don't think I'm just making it up. I promise it is a real standard. And so we'll just look through kind of how this can help with the cybersecurity lifecycle and work in industrial control systems. So important things to consider are that it is owned by operations technology and information technology. So it's important to kind of understand the relations between those two fields and how they can work together to improve cybersecurity. And again, it does go through the assess phase, the implement phase, and the maintain phase. So it's across the entire life cycle of a facility. So now we're going to look at a couple examples of where there were cybersecurity incidents and what happened. So the first we're going to talk about is the Maroochy Shire incident in Queensland, Australia. And so this incident actually occurred back in 2001. So it's important to realize that although the amount of cyber attacks is greatly increasing in recent years, they've actually been occurring for quite a long time. And so what happened in Maroochy Shire is a third-party integrator came in to upgrade their system. And so they were, updating the SCADA system and adding some remote access capabilities. And there was an employee in this integrator that had a falling out and actually quit and then tried to get a position at Maroochy Shire. When he was eventually denied this request, he then began initiating a cyber attack. And so he stole a laptop from the contractor and then used this to gain remote access to the system. The attack resulted in the release of 264,000 gallons of raw sewage released to residential areas, parks, really causing a huge environmental impact. And the contractor, because of the attack resulting from their equipment and their employee, was fined $500,000 for this incident. Another important incident that's relevant to SCADA systems is actually an attack on a New York dam. So this happened in Rye Brook, New York, and luckily it was only a small 20-foot dam. But the SCADA system is very similar to what you see even for much larger dams. And so what happened was Iranian hackers gained access to the control network for the dam, and many experts believe that this was actually a retaliation to the Stuxnet attack on Iran. And so they overcame weak security features in the cellular modem and then were able to establish remote access that way. Luckily, the sluice gate for the dam was actually removed from the system for maintenance because otherwise the attackers would have had hands-on keyboard access and actually been able to physically release water from behind the dam. When we start to look at the IACS security incident data, we see that it's a 20-80 split between intentional attacks and unintentional attacks. So even though intentional attacks are what are typically focused on in the news and what we might hear more about, unintentional attacks still represent a very important threat. And one example for this was that there was an automated dairy farm. And so an operator was trying to log on to shut the system down before going home for the weekend. And the first time he logged on, it didn't quite work and he was confused, so he did it again and then eventually shut the system down. When he came back from the weekend, he found out that the first time he logged on, he had accidentally logged on to a different controller IP address by making a typo. And so he had shut down another automation system for the dairy farm that was maybe 20 miles away without intending to. And so this is an example of an unintentional attack that can still lead to process downtime. So the next slide, we're going to talk about some statistics for the amount of worldwide SCADA attacks. So we're just going to do a quick poll to see how many attacks people think there were, and this is information coming from January of 2014. So we'll just quickly get a look at how many attacks we think there were in this time period. All right, we'll leave it open for another 5 seconds, get your responses in, and then we'll look at the results. Okay. So what we see is we've got half of people thinking between 1,000 and 10,000, with then a little bit less thinking less than 1,000, some thinking, more than that. So when we go to the numbers, we actually see that there were over 600,000 cybersecurity incidents just in January of 2014. So this is a huge number, and it really comes down to the fact that there are so many more systems active now, and that there are so many different types of cybersecurity incidences. And this is more than 6 times greater than in January of 2012. So we're seeing a very sharp rise in the number of cyber attacks. So the question then becomes, why are SCADA systems targeted? And we see that the likelihood of a successful attack can be broken down into the product of 3 different factors. So it's reliant on the threats, the vulnerabilities, and the attractiveness of the target. So when we're talking about threats, they could be either internal or external threats. When we're thinking of vulnerabilities, maybe the prevalent use of remote controls really does increase the attack surface for the network. And then for target attractiveness, it could either be, as in the case of Maroochy Shire, a personal reason for attacking the target, such as revenge, or it could be maybe it's a critical utility and they're demonstrating, as in the dam attack, that there is a credible nation-state attack against infrastructure. So it's just important to keep those 3 factors in mind when we look at securing remote access. So the basic part of securing remote access is to use access control. So this is the same access control that you would use for regular access at the physical plant, but then you have to step it up a bit because remote access does introduce a greater chance of threats. So it's important that you require and enforce access control both through your own employees and also vendors and contractors. And you also should make sure that company-owned laptops are specifically used and maintained for remote access. When we take a deeper dive on access control, we want to look at the 3 A's, and I know there are 4 on the screen, but account administration still just counts as 1. So we've got administration, authentication, and authorization. And these are really the ways in which you make sure that access control is effectively implemented. When we talk about account administration, it's really the idea that we only want to give access to specific people, and for remote access, specific devices as well. So we can use MAC filtering to make sure that's only specific users on specific devices who can interact with the system. We also want to restrict where they go into the system when they get access. So for remote access, it's typically best practice to send them to a jump host before then letting the jump host determine what other systems are allowed to access. Finally, for remote access, allowing local PC users to confirm or deny access helps prevent any confusion between local staff and people working remotely. And then finally, monitoring and logging the ID, time, and duration of remote access sessions can make sure that if an incident does occur, you're able to identify what went wrong and when. And that actually turns out to be a very important step in identifying, when threats were introduced. For authentication, really the goal is to prevent the effectiveness of brute force cyber attacks. So someone plugging in a program and trying a bunch of passwords and then having access to the system. So a couple of different steps that can be taken to prevent this are requiring the use of strong passwords. And then the next step better is really requiring multi-factor, 2-factor or greater authentication for any remote access sessions. So this now requires operators to have something that they know and also something they have. So something they know would be, a strong password that they need to log in, and then something they have might be their work cell phone. So they get a verification code sent to them, and they have to confirm that it is them logging on. So this way, just because someone has their password does not mean that they're able to log on to the system. Additional practices would be to disable an account after a certain amount of failed log attempts, again, to prevent someone from just trying a bunch of different passwords. And then after a period of inactivity, require that users re-log on. Next, when we think about authorization, we want to make sure that when people are logging in remotely, they're only authorized to do what they really need to do during their remote session. So this would include requiring ushered access for vendors and contractors, so kind of similar to sending them to the jump host first and making sure that you have personnel kind of monitoring and leading the access. Then we also need to have workstation policies and protections to prevent unauthorized PCs from starting remote sessions. And then finally, when someone is starting a remote session, you want to make sure that they only have specific access rights that they need for the remote session. So typically you wouldn't want to give someone unlimited file transfer rights during a remote session, because this is where you could have someone remotely log in and then transfer out business critical information in kind of a data theft type attack. In addition to access control, it's important to take steps for system hardening so that the devices and wireless network that you're using really is set up in the most secure way. So this can be looked at just basically for some general configurations, both for the wireless routers, so the TCP ports used for remote access protocols, as well as configuring the security for remote access software to be as secure as possible. And so we see this also with VPN specifically in not allowing split tunneling, so you really only have the one point of access during a remote session. Additionally, encryption is very important so that attackers cannot easily see information going between a remote session and the local network. And then additional steps would include using intrusion detection systems on any traffic over a VPN tunnel. So this will give you an alert in case an attack is being initiated over the remote access. Next, we'll talk briefly about some additional security steps for wireless networks. And as we said before, there are the two main types, the wireless LAN and the sensor-based. These recommendations are kind of specifically focused on the wireless LAN, but could, the same ideas about policies and procedures, segmentation, and system hardening can also be applied for sensor-based technologies. So in addition to having, the basic cybersecurity policies that we've talked about before, you also need to make sure that remote access is segmented from the local network. And so typically this is done using a firewall or similar device. Now, the example we have here shows remote access going through a firewall and then accessing the business information network. But you could also have a remote connection that was going in and accessing, sensor level devices or your control system. And so typically what you'll see here is instead of a firewall, a managed switch is used to route traffic and then restrict traffic, so only the necessary applications and protocols are running between the wireless LAN and the wired network. You also want to make sure that your network is segmented from other broadcasts so that you're not getting interference from just general broadcasts through the wired network. And then lastly, you want to make sure that you're strictly prohibiting the connection of any wireless equipment directly to the IACS unless it's approved for use. So whitelisting specific device applications and equipment that you want to use for wireless network. Next, we'll look at some different system hardening steps for the wireless LAN. So much like for configuring the VPN, you never want to use the default security configurations for the wireless access. And this would include disabling the SSID beacon, which basically just transmits the name of the wireless network, so it's easier for attackers and other people to find. Another good policy for this is to not use an easily guessed identification name. So that way, if someone does find it, they don't necessarily know what that wireless network is for. Additionally, using static IP addresses for devices is typically best practice because it allows VPNs to access the same devices and allows for more effective whitelisting of devices based on their IP addresses. Additional system hardening includes the use of authenticated access, as we talked about earlier. as well as using strong encryption for your wireless LAN. And so typically we try to advise people not to use the WEP encryption because it can be easily cracked, but something like WPA2 typically is stronger. Now, even with WPA2, we have seen very serious vulnerabilities even in the last year, and there's a crack vulnerability that allowed attackers to actually gain access to the information being sent, and in some cases even modify it. But this is, again, just a reason to make sure that you're staying up to date on all of your software and keeping it updated. Then, as before, really monitoring access attempts to the wireless LAN and scanning for unauthorized access points can help you identify if an attack is occurring, so steps can be taken before the final objective is reached. So finally, we'll just do a brief word of caution on denial of service types attacks and how they can affect wireless systems. And so denial of service type attack is basically where there's a prevention or interruption of authorized access to a system. So something blocking out your communications. And one example I like to give for this is recently exida was reviewing certifying a remote emergency stop button for an offshore oil platform. So we wanted to make sure that the device gave set reliability so it could be certified. But when we started to ask questions, we found out that whenever the Navy would drive by the oil platform, the entire wireless communication would be shut off. So you would not be able to get a signal from the emergency stop device to the platform because the Navy was blocking out all the signals. And so we wanted to dig a little bit deeper, ask them, okay, well, how long are they there? And it turns out that the Navy would stay as long as they wanted. There's no set way to figure out when that was going to be. So obviously, we weren't able to certify the device, and it just goes to show that with wireless networks, it is very easy to jam the signal and prevent access from occurring. So while the industrial Internet of Things may be a really great solution to operations and maintenance types activities, for critical control functions, it's still not would be recommended as a reliable way to achieve that. So what we're going to go on from here is just a brief summary of what we talked about today. So first we discussed the industrial Internet of Things, how that's becoming more relevant for automation systems. Next we discussed general risk management practices for IACS and SCADA systems. And then we went through some specific case studies of successful attacks. And finally, we discussed different steps that can be taken to secure remote access and wireless networks. So the question then is, how can you improve your cybersecurity readiness, specifically considering remote access and wireless connections? So the first step is always to identify where you are, get an understanding of where your system is currently at and what cybersecurity countermeasures you have available. Next, it's identifying what process, procedures, and competency you can leverage to make sure that you're operating correctly and that you're not introducing the potential for more attacks. Finally, it's performing a detailed evaluation of your system and figuring out the countermeasures and specific risk for different devices so that you can more actively manage cybersecurity risk. And what we see is exida can provide a lot of different support for all three steps in improving cybersecurity readiness. So if you're just trying to identify where you are, we can provide support with a gap analysis, or it may be good to review gaps internally and figure out what metrics you're going to use to measure cybersecurity readiness. When it comes to improving process, procedures, and competency, exida has a wide range of templates, many training courses, as well as the CECE and CACS professional competency exams. And then when it comes to detailed analysis of your system, we can support both high-level risk assessments, detailed risk assessments, and cybersecurity vulnerability assessments. So if you're interested in learning more about any of these topics, please feel free to talk to an expert, request a quote. I'd be happy to talk to you about any questions either from this webinar or in general about cybersecurity, and my contact information is on the screen, so please feel free to reach out to me. Additionally, if you are interested in following us on social media for all the latest updates, don't be afraid to follow us at exida LLC or exida.com LLC, depending on the application. We also have a number of upcoming training courses in a wide range of functional safety and cybersecurity topics. So if you see anything in your area that you're interested in attending, or you don't see something and you would like to know more about courses, please visit exida.com/training. And then lastly, I'll take a few minutes to answer some questions and go back through to make sure that I got them all from today. So I see one question that I missed earlier, and so that was, oh, actually, I see a bunch of questions. So I apologize. It's my first time trying to go through the question things. So the first is, what are cyber incidents but not necessarily attacks? So that is a really good question. So that goes back to the statistics we looked at for the number of cyber incidents. So if we think about the intentional versus unintentional cyber attacks, something that's intentional would definitely be categorized as a cyber attack. But the unintentional, say the operator logging on to the wrong remote access system and accidentally shutting it down, that would be referred to as a cyber incident because it wasn't an intentional attack, but it was still a business consequence resulting from a cybersecurity field. Okay, let's see, next one. All right, would I elaborate about blocking the signal? What are trends to overcoming this problem? Okay, that's a really good question. So essentially, wireless networks communicate over a set frequency, and for the sensor-based, they speak over radio frequencies. And there are a couple of different protocols, either the TCP or remote transfer units, RTUs, can be used for the sensor-based depending on if it's an Ethernet or serial connection. And so we see that some of these protocols go on different wireless frequencies. They actually kind of smartly identify what best wireless frequency to go on. And so they're somewhat more resilient to blocking the signal. But typically what we see is if someone sends out a jamming signal or is knowledgeable about the process being used for the wireless network, it typically is not too difficult to block that signal from going through. So maybe you would block someone from seeing the wireless sensor, so they don't have a read on what that tank level is. And maybe you can put up with outages for something that's operations or maintenance based, but you can for something that is a critical control of the plant. So it's okay if you don't know what the tanks are every time, as long as you can see them often enough. But if you're not able to use an emergency stop device when you need it, it's really not going to be a good use of a wireless network. So I hope that answers that question a little bit better than in the presentation. Okay, any books you recommend to jump into for wireless cybersecurity? So that is a very good question. I guess I was a co-author for the IEC 62443 Lifecycle book that I talked about, so I will happily recommend that to everyone. I think it's a really great book and a good place to start. That has a couple sections that cover remote access and wireless cybersecurity, but off the top of my head, I don't have another good reference book I'll recommend. But I'll definitely be sending out answers to this question in an email to all the participants, so I'll see if I can find a good recommendation to include in that. Okay, the next question. What kind of security should we have for wireless instruments connected to the PCS, so process control system, different things like that? So this goes back to a lot of the slides in the second half of the webinar. So I'll hop back there quickly just to look at just the general principles that we should be considering. So for wireless instruments connected to the PCS, sorry, I went back too far. So it really comes down to the policies and procedures for using these instruments, the segmentation from the local control network, and the system hardening done on them. So the first step is always to make sure that the wireless instruments they're segmented from the local control network. So you don't want wireless instruments to be directly speaking to the control network as a whole without going through the jump server first, or without being routed through either a firewall or managed switch, depending on the system. So that's kind of the general upper level things that you should do to make sure that it's secure. And then when it gets down to actually the security for the wireless instruments, that's when it really gets into system hardening and making sure that you're using robust security features. So what we saw in the New York Dam attack was because the modem was just on its default security settings, it was very easy for the attackers to gain access to it. So you want to make sure that you're using the most robust security configuration possible for the wireless network and the wireless instruments, and making sure that you're whitelisting when possible and doing different steps to make it more difficult for attackers to get access. Okay, so that looks like one of the last questions I have here. I'll leave it open for a few more minutes if anyone else has questions they want to ask. But thank you very much for being a great audience. I really appreciate all of the participation with the polls, and yeah, I really appreciate you guys' time today. So if we don't see any more questions, we'll go ahead and close the webinar. Alrighty, it looks like we're good. Thank you guys so much for your participation and have a wonderful rest of your day. Bye.